Hi everyone. We're going to start chapter 4 now. It's a chapter on linear relations. And just to give you some context for linear relations, if you aren't already familiar, linear relations is what we use to analyze data or determine trends or, find patterns in things. So one of the examples I said here was how have music sales changed over the past 10 years or 20 years? And how have music formats changed over the past years? And why would record companies be interested in keeping track of these data? So that's all to say that it helps us to know year over year and over a period of years what's going on or what trends there are, so we can make modifications or corrections or adjustments or whatever's necessary. So it's very important stuff used everywhere. And the next one, can you predict the next number in the pattern 5, 9, 13, 17? And then can you find the 100th number? So all the things we were doing in chapter 7 sort of leads us to this, and these actually will be much simpler sequences than what we were seeing before. But I will start here and make a table of values, which is how I like to do it. 5, 9, 13, 17. So I used to work in the airline industry and revenue management, and everything we did, we kept track of every aircraft, how many seats went full, how many went empty, did it go on time, did it go late, how much were people willing to pay. The group is called Pricing and Yield Management. So we set fares based on this demand and the supply of seats. So we had to know all of the information about all of the flights. Okay, so term, let's see, oopsie, I did that wrong. Term, I was distracted. 1, 2, 3, 4. And we know that it's going up by 4. So, oopsie, so we do this. So we know it's going up by 4. So then I would say before we try and find the 100th number, why don't we find the 5th number? So if we find the 5th number, we know, well, the 5th number is the value of the 4th number plus 4. So that would be 17 plus 4 is 21. And then if we wanted to find the 6th number, well, the 6th number is the value of the 5th number, which is 21 plus 4. So that equals 25. Okay, so in this way, then we can find the 100th term, because the 100th term is going to be the value of the 99th term, the value of this one, plus 4. Okay, so if we wanted to put it into sort of fancy lingo, you could say this is t of n minus 1 plus 4. And so then n would be n equals t of n minus 1 plus 4. Okay? But that is that. Value at 99. So it would be very difficult for us to calculate the value at 99 if we just were crunching the numbers. So that's why I just put, well, okay, so let's call it something. Let's call it the value at n minus 1. Okay. So here it says determine the perimeter of the 10th set of plots. So the situation is that a landscape designer uses boards for the edging in an herb garden. The number of boards, B, is related to the number of plots, P. Well, so let's see, plot 1, that's this T. So plot 1, 2, 3, 4. So plot 1 has 4 boards. And plot 2 has 2, 4, 7, has 7 boards. And plot 3 has those 7 plus 3 more, which is 10. And plot 4 has 13. So we're going up by 3, right? So if we want to represent the number of boards, B, related to the number of plots, P, well, the plots, P, equals B plus 3. So B of the previous one, n minus 1, plus 3. So, oh, here I did the table of values there. Represent equation to represent the relationship. So n equals 4 plus 3n. Okay, so the next one is, it says determine the perimeter of the 10th set of plots. So we'll do this here. Okay. And so the situation is a landscape designer uses boards for the edging in the herb garden. The number of boards, B, is related to the number of plots, P. Well, so because if we have this one, it's 1, 2, 3, 4, so it's 4 boards. And this one is 4 plus 3 more, which is 7 boards. And this one is 7 plus 3 more, so it's 10. And then this is 10 plus 3 more, so it's 13. Okay. So the relationship between the boards and the plots can be represented in 3 ways: using pictures and words, using a table of values, and using an equation. So here we have the pictures. Let's look at a table of values because it helps me visualize what's going on. So the term 1, 2, 3, 4, and the value is 4, 7, 10, 13. And so if you look at it, so 4 to 7, you add 3. 7 to 10, you add 3 again. 10 to 13, you add 3 again. Okay, so then you could come up, so it says next write an equation to represent this relationship. Well, you could say 1 is 4, term here. 2 is 4 plus 3, because that's 7, right? 3 is 4 plus 3 plus 3. 4 is 4 plus 3 plus 3 plus 3. And you see that you have 3 3s here on the 4th term and 2 3s here on the 3rd term. So the number of 3s you're going to have is going to be 1 less than the term you want. So suppose we try for term 5. Term 5 would be 4 plus 3 times 4. Right? Hi, in re-watching the video, I realized that I left out a piece from before. So I'm going to do that piece now, and then I'll edit it back in. So it's about the boards and the plots. So the boards, we have plots of 1, 2, 3, 4, 5, and we have the number of boards that are in those plots listed here. And we had our ratio, the common difference is as 3. So I just wanted to show you that the equation comes from, in this case we have, I think I'll use black. So we have 1 plus 3 gives you 4, and 1 plus 3 plus 3 gives you 7, and 1 plus 3 plus 3 plus 3 gives you 10, and 1 plus 3 plus 3 plus 3 gives you 10. Now it gives you 13. So then what we wanted to come up with the value was that this is 1 plus 3 times n. So now before, I think I started with 4. I said, okay, let's start with 4. But really you can start with 1 and go up. So 4 is 1 plus 3, and then 1 plus 3 plus 3. So it's all in it. So 1 plus 3 to the n is the equation for the increasing plot size. Or 3 times n, excuse me. So now you can plug any number into there and figure out how many boards you're going to need or what term you're at. Okay, the next problem is a problem about still linear relations, but in this case we use an example of a party where you're sitting at a table. And so at this party you have a table that seats 4, and a table that seats 6, and a table that seats 8. And then the tables, because they can be pushed together to form longer tables. So now the question is, what are the next 2 table arrangements that we could have in this example? So, like for instance, I'll just do table 4. 1, 2, 3. And so you could have 8. So this table is the first term, so to speak, the second term, the third term, and the fourth term. Now I'm not going to draw the 5th term, but I am going to make a table of values though. So if we had a table of values for this, we would have, okay, the term and the value. So the term, for term 1, table 1 had just 4 seats on it. So that's the value, is 4. And table 2 had 6 seats on it. And table 3 had 8. And table 4 had 10. And then table 5, I think you figured it out by now, will have 12. So that's an increase of 2 for each change. Okay. So the next part of the question asks us to write an equation to represent the relationship. Well, it's nice to have the table of values to write the equation. So you could say, all right, I'm going to start with 4. And then for 6, I'm going to add 4 plus 2. Right? Because we added 2 from the 4. And the 8, well, that's 4 plus 2 plus 2. Right? And the 10 is 4 plus 2 plus 2 plus 2. And this is very much like the last problem where we had very similar situation with the constant adding of the 3's, right? So if we have this, then we notice that for term 4, we only have 3 2's. So if we make an equation, the equation would be ... So it would be 4 plus 2 times n minus 1. If you say the nth term is 4, then it has 3 2's there. I'm going to rewrite it up here too. We'll start n equals 4 plus 2 to the n minus 1. And And as I mentioned, we got that because the number of 2's that you're multiplying by is 1 less than your n. So then that equals n equals 4 plus 2n minus 2. So n equals 2 plus 2n. And that's our formula. All right, so then if we want to apply that formula, we'll use the equation to determine the number of people at 6 tables. So if that means that n equals 6, and we just did number 6 here, or 6 down there, but 6 tables equals 2 plus 2 times 6, which equals 14. And it says determine the number of people at 10 tables. Well, that would equal, put it in here, 2 plus 2 times 10, which equals 22. Okay, see the pattern? And then 25 tables equals 2 plus 2 times 25, which equals 52. Okay? And then we can also do it the other way around. So if we had, it says how many tables are needed to accommodate 100 people. So in this case, we know our n equals 100. So if you put that on this end of the equation equals 2 plus 2n, and solve for n, well, so that's minus 2, which equals 98, equals 2n. So in this case, you'd need 46 people to accommodate, 46 tables to accommodate 100 people. All right, so let's move on and go to the next piece. So it says, Kelly's taxi service charges a fixed cost. So here's Kelly. That's how you spell her name, Kelly Taxi. And then it charges a fixed cost of $3.60 plus $1.50 per kilometer. So she charges $3.60 fixed plus $1.50 per kilometer. And it says write an expression for the fare in terms of the fixed cost and the cost per kilometer. Okay, well, the fixed cost is only once. So like the 2 situation we had before where you added 2 each time, in this case we have just this 360. So this is like the 4 that was in the last equation. So it was 4 plus 2 and 4 plus 2 plus 2. So in this case, the 360 is like the 4. So you have 360 plus, and now you don't know how many kilometers you're going to travel. And that's just like the number of 2's. You don't know how many 2's you're going to end up with. Depends on the term, right? If the term is 1 or the term is 200. So in this case, for each kilometer, you're going to have to pay $1.50. So $1.50 times however many kilometers there are. Sorry, I'll put KM in here. So that's your equation, and that's your fare. Fare equals $3.60 plus $1.50 per kilometer. So the next question is how much? Suppose we go on an 11-kilometer ride. Then what is the fare? What is F? So we can figure that out simply by doing the same sort of exercise that we just did. So you could say F equals 360 plus 150 times 11. And that gives you $20.10 for an 11-kilometer ride. Okay? All right, let's do another example. Okay, Clint has a window cleaning service. He charges a fixed cost of $12 plus $1.50 per window. So window cleaning, W. Okay, so he has a fixed cost of $12. So this is flat. It comes every time, no matter what you do. If you have 5 windows cleaned or you have 100 windows cleaned, you're always going to pay this $12. So, and then plus $1.50 per window. Okay, so write an equation that relates the total cost to the number of windows cleaned. So the cost equals, like I said, you always have the $12 because that's flat rate. That's what he charges just to come to the house or do whatever, go to the building, plus $1.50 times however many windows there are. Okay. So here the question is, he charged $28.50 for a job. How many windows did he clean? Well, if he charged $28.50 for a job, how many windows did he clean? Well, you put it right into the equation, plus 1.5 times W. And then we can solve for W, right? So minus 12 and minus 12, so this equals 1650 equals 1.5 W. So, and then W equals 11. So 11 equals W. So he cleaned 11 windows. He got paid $28.50 and he cleaned 11 windows. They must be very small windows, and they certainly aren't up on a high building. Okay, the last one I want to go through is there's a pizzeria, and they have a lot of different toppings. And in this case, the plain pizza with tomato sauce and cheese costs $9. So the pizzeria, and a plain pizza is $9, and plus 75 cents for each topping. I'm going to say this is the cost. Okay, create a table that shows the costs of a pizza for up to 5 toppings. Okay, so if we have this table of value, so this is the cost and this is the N or T term. 1, 2, 3. So the first one, right? Let's see. Create a table that shows the cost of a pizza for up to 5 toppings. So, well, the first one with 1 topping, okay, is 9 plus 75, or $9.75. And the second one, using the same logic, is $10.50. And the third one is $11.25. And the fourth one is $12, and then $12.75. Okay, so there's your table of the toppings and the cost of the pizza with each incremental topping. So then it says, write an equation that relates the cost in C dollars to the number of toppings, N. Oh, she calls this N. Verify your equation by substituting values of n from the table. Okay. So the cost of the pizza was based on the number of toppings is 9 plus 0.75 times toppings, t. That's your equation. And they said, well, verify that using this table of values. So, and I can say, all right, well, C equals, if I want 4 pizza or 4 toppings, it equals 9 plus 0.75 times 4, which equals 12. So I'd say we did a pretty good job there. Okay, suppose a pizza costs $15. How many toppings were ordered? Well, if pizza costs $15, then I'm going to just substitute that right in, plus 0.75 t, and then subtract 9 from both sides, and that gives you 6 equals 0.75 t. And that means you have 8 toppings, right? It's 4, so 8 toppings. T equals 8. They like fall over. I don't know. I like a couple toppings. I like arugula. Do you like arugula? Yeah, it's the best. Okay, so I think that's it for now. So thank you very much for listening, and we will see you next week. Alrighty.